The distance from the point P to top of the wall from a Q on level ground is 24 meters. The angle of elevation, so that means that elevation would be this one down here. If I said angle of depression from the top of the wall, that would mean that one there. Okay? Now it goes, angle of elevation from P to the point Q is 29 degrees. Calculate the height of the wall, correct 2 decimal places. So I have to calculate what is the height here, okay? So here's what we're going to do. Dennis, you looking? Dennis, yeah. Lads, what is, compared to this angle here, which is at 29 degrees, what is the label for H? Adjacent, hypotenuse, or opposite? Opposite. So you know the opposite. What's the 24 meters? Hypotenuse. Then you put in your rhyme, because you're always going to use your sequence of letters there. Which one do we use? We want to find the opposite using the hypotenuse. So sin. Okay. Now, what goes beside the sin? What goes in here? It's always the angle. 29, and that equals h over 24. What do we do next? We're not using sin inverse because we're not finding the angle.
24.
Or that's the same thing as bringing the 24 back up. Okay? Put that into the calculator. So we put that into the calculator, 24 sine 29. Tell me what you get.
Well, sorry.
Huh?
Did you say it equals h? 11.63.
11.63. 11.63 because it specifically says, baby looking, correct to 2 decimal places. Is that alright? Yeah. So you can see, although it's dressed up in new language, it's not that bad, okay? Yeah.
It's not 6.4.
6.354, so it rounds up to 6.4. Okay, we're good. Now lads, we have next is next one is a girl is flying a kite, okay? The length of string from her hand to the top of the kite is 60 meters. The string, which has been held 1 meter from the ground, so she is currently 1 meter off the ground where her hand is, okay? And she makes an angle of 50 degrees with the horizontal. So 50 degrees here. Okay? Now, just for the sake of it, okay, I'm going to bring in the clinometer for a second, just to show you how it could be used in this question. Now, it gives you the angle already, but I just want to show you how it could be used in this type of question. So, if you imagine I turn this one upside down, like so, and then, wait a second, then I bring it in here, and then we have our weight hanging from the bottom. So our weight is currently going through the 90 degree mark. Do you see that? Now, when I tilt this clinometer upwards, and it goes up to 50 degrees, yeah? You can see that the reading on the clinometer now is 140, and it was 90 degrees. And what's the difference between 140 and 90? 50 degrees. So that gives me our 50 degrees height difference, okay? Or angle of elevation. Alright? So, we're given that in the exam, but you might be asked in the exam to actually, you go, how would you measure this? And you say with a clinometer, then it might ask you, give it an appropriate angle. So you might just say, look, 40 degrees, and then you proceed with the question with your own angle. Okay? So what happens then, lads, is I'll just get rid of this for 1 second. There it is, gone. Okay, and there. Okay, so it's 50 degrees, and so we have a right angle triangle. So you can see it's all about using right angle triangles at the moment. So that's 90 degrees there. Now what does it want me to do? It wants me to calculate the height above the ground to the nearest meter. Now the height above the ground is technically this red line here.
The opposite.
Okay? The opposite side that you're talking about, and you're right, is this yellow line here. So what do I need to do? Once I find the length of the yellow line, what must I do after I do that? Add on 1 meter. Because it's 1 meter in height, it's this 1 meter here. So I'm going to find the yellow line, which is the opposite. Let's call it X, and it's the opposite side. What's the 60 meters?
Sin.
Hypotenuse. And it will lead to being sin. So sine 50 degrees is opposite over hypotenuse. Multiply both sides by 60. And then,
Say about 45.
so put it into calculator and let me know. Yes, Sean?
How did you get the length of the opposite again?
I didn't. It's x.
Okay.
And I'm about to calculate it now.
Oh, when you get it, you'll add it.
When I get it, I'll add on the 1 to find the height. What is it?
45 plus 46.
46? Okay. Now guys, to go describe how the angle of elevation might be measured. I already described that, didn't I? You get a clinometer and line it up with the kite in the sky. That's no bother. Alright? Now, the only one that's remaining is the tree triangle system, okay?
So does that mean that woman's only 1 meter?
It's probably a child, yeah.
Oh, wait, perfect.
Okay, alright. Okay, when a person stands on level ground at a point 100 meters from the foot of a vertical cliff, the angle of elevation from the cliff is 40 degrees. So what happens, lads, is when you walk closer to, if you have a tall object in the distance, like a skyscraper or a building, the closer you are to the foot of the building, the higher you have to look up to see the top of the building. So basically this angle here, angle B, will be smaller than angle A. Always. You notice that if you've ever been to America and you're looking at one of the buildings in the distance, you don't have to look, you don't have to re-tilt your head, but the minute you're right underneath that building, your head has to tilt a lot to see the top. Okay, that's just common sense. Now, to go calculate the height of the cliff. So the height of the cliff, lads, is this here, which we can obviously assume that it's a right angle triangle because it's going directly up, right? So anybody have any suggestions on how to calculate this?
What sides do you know? Just the adjacent?
We only know the adjacent and the angle, and we're looking for the opposite. I know I called it H for height, but it's actually the opposite, okay? We'll call it X actually just to stop confusion, okay? So, Sam suggested tan, because we want the opposite, but we have the adjacent. So tan what, Josh? What goes beside tan?
40 degrees.
40 degrees. The angle always goes beside tan. X over 100. Now what happens next?
Bring the tan over.
No, you only bring the tan over when you're finding the angle, Josh. You bring the 100 top and bottom. David, cross off the hundreds. Put down to the calculator, let me know what you get. 100 tan 40.
84.
84. Okay, meters. If the person moves to a different point on level ground, 244 meters from the foot of the cliff, what would the angle of elevation be then? So he goes all the way back. So if you're looking at this, it's basically we're going to use this triangle here. I'll show you now. We're using this triangle here. Basically that triangle there. So with this triangle, just draw it over here. We have 244 on the bottom. And we have 244 on the bottom. We know that the height is 84 and we need to find out the new angle of elevation. Let's call it Y. What are we expecting? Bigger or smaller than 40? Bigger or smaller than 40? Sam? Do you know we're expecting a bigger angle for here than 40 or a smaller angle than 40?
Smaller.
Smaller, right? Because you're further away. When you're further away from an object, you don't have to look as high. So, how would you find out this angle here? Opposite and adjacent. And then what will I write down for opposite and adjacent? Tan Y equals 84 over 244. Josh, in this case, you don't know the angle. So therefore you're moving the tan this time. So what happens when you move the tan over to your side? Tan inverse 84 over 244, and what do you get? 19? Okay guys, so that's it done. Right there. Okay.